for this talk, and thank you all for being here. Really wonderful to see you all here. I was presenting in last year's Cypher 24, and somebody had asked me a question. I was again talking about generative AI in Snowflake and so on. Somebody asked a question that, can you work on multimodal data as well? Do you have models which can work on multimodal data natively in Snowflake? So my answer that time was, yes, we can do it, but in a customized way, not natively in Snowflake. We can deploy those models into a container and so on and so forth. I'm very happy that the very topic this time is on multimodal data and how we can work on it natively within Snowflake platform, right? Now, I don't want to use this as a fancy term called multimodal data. I think you all probably understand that, but the way I like to think about this is it is adding some more dimensions to the subject that we are interested in. Just like we have modalities in hospital, X-ray, MRI, so on and so forth, we're basically adding more dimensions to the data. Let's say customer 360 or a patient 360 or maybe a particular workflow, so on and so forth. So far, we have been very focused on the structured data. We've all been focused on structured data a lot for many years. What generative AI suddenly did is allowed us to tap into this unstructured data. Right? We have been saying that 80% of the world's data is unstructured for a very long time, right? The problem was it was not easy to tap into that unstructured data. It was really difficult. We did have some machine learning capabilities in the past, like NLP, computer vision, and so on, but it was very hard. What generative AI did is expose those models as API endpoints that we can suddenly talk to and then operate on this audio, text, video data and get more insights from there. At the same time, when enterprises started to deploy these GenAI models, they had to struggle with different kind of challenges, like their security and governance boundary, creating these pipelines between the data and the AI platforms. You do want to bring all this data in a single place, right? Just to make sure that you know what you're working with, it is consolidated, you're able to combine that with structured data. And then you need to take it to the AI models, which are sitting behind maybe an API endpoint or deployed in a separate place. Now, how do you build these pipelines end-to-end? That still requires some bit of expertise and knowledge of how to work with these. You still need to whip up a Python code and then make all of this work. What Snowflake has really done is, even if you are a SQL data analyst, even if you are a data engineer, you can operate on this data as if it is just a structured data. That makes it really, really simple and easy to operate on this multimodal data and add these insights to the never-ending quest for 360-degree view of something, be it a customer, patient, or a company, and so on. Yeah? So we are adding more and more dimensions to the same data with these multimodal data analysis. Can I know in this room how many of you are data engineers? Oh, quite a few at the back of the room here as well. How many of you are AI engineers who like more focused on AI, ML? Okay, wonderful, wonderful. Any SQL analysts here in the room who operate purely on SQL? There are a few as well. Wonderful, wonderful. So what this does is basically combines all of them together. Whether you're a data engineer, whether you're a SQL analyst, or whether you are a data scientist or AI engineer, you all can make use of this capability in a very simple and easy way. So the boundaries are kind of merging because all these disciplines are overlapping with each other, right? So the multimodal data analysis in Snowflake really makes it easier to merge those boundaries. And thanks to Mr. Rajgopal, he talked about how sovereign data centers can really help build these capabilities within the country. Now, that is all abstracted from the users, right? They really don't care about what's behind the scenes, the models, the infrastructure, and all of that is very important to make sure that we have control on that as an infrastructure layer. But as a user, you want to know how to make use of all these capabilities. And then we create transformational impact on the business with those capabilities. So just to cite some examples, how can you really make use of this multimodal data, right? So you can use this to do things like A/B testing of ad creatives. So when you're coming up with a visual imagery and coming up a particular marketing campaign, you want to know, hey, what kind of imagery is having more impact? What kind of advertisements are having less impact? Correlate that with the footprints and then do a quick testing over there. Now, it wasn't very easy so far. You would probably be doing a lot of manual tagging and then associating the outcome. Now, with multimodal data analysis, you can look at the images, then find out what's the image like. What's the color style? Is there a human in the ad? And then correlate immediately with the rest of the ad marketing campaign impressions, and so on. So we talked about advertising creatives, how do we get more insights from there, along with structured data. There is also a lot of manual tagging and labeling which happens on these images, and a bunch of people who are annotating these images and labeling them. We can free up their time and automate this process of labeling and annotating. That's another example. In customer call centers, we are fielding these calls day in and day out. How do we get sentiments out of that? And not just the customer sentiments, but also things like agent professionalism, how long the customer had to wait, and so on and so forth, in a much easier and simpler way. So that's on the voice data. And then you may also want to look at the complex structured documents, like balance sheets of a company, quality inspection reports, manufacturing SOPs, and then from there want to extract how do my people work better with this data. So if I'm doing an analysis or an investment advisory, I can look at all of this unstructured data, populate that as tables in my database, and then run queries on top to get easier insights. So these are some of the examples. Let's also look at how some of these customers who are using multimodal data with Snowflake have created impact with that. So let's take healthcare, different verticals. One of the healthcare providers, Alberta Healthcare, what they do is in their emergency rooms, when the doctors are talking to the patients are describing the situation, they use this to transcribe the interaction and then create summary notes out of that. So that doctors don't have to worry about, are they taking the right notes, have they described the scenario well, they can talk to more patients in the ER. So that's an example of multimodal data in healthcare. Now, you look at a company like Nissan, what they do is they talk to, they collect customer feedback through organic forums. They also look at inorganic surveys, which customers go to those forums and give their own feedback automatically. They look at all this data and then drill this down to the dealer level and say, hey, which dealers these customers are more happy with, which products are they more happy with, and so on. In the digital media side, if you look at SKAI, what they do is they help these digital media companies connect with e-commerce platforms and then advertising platforms. One of their clients had to do product categorization of their e-commerce products, about 10,000 products, and they had a very tight deadline of 2 days. They were able to do this for 100,000 products in 2 days time flat with about 99.8% accuracy. All these product images, they basically generated a description and categorization and then uploaded to wherever those images were basically posted. Yeah? So very quick outcome and very accurate outcome. Then you have companies like Penske, which basically looks at their associates or driver safety records and then create personalized recommendations by operating on that data. Now, if you are a data engineer, you already worked on structured data, you know this pattern. This is nothing new. You already are very familiar with this, getting all the structured data into one place, transforming it to make it more ready for consumption, and then making it activated through various channels and consumption tools. Now, the good thing is, you can apply exact same paradigm for unstructured data as well. You're already familiar with this framework. We are going to apply the exact same thing for unstructured data as well. This could be sitting in your SaaS applications like SharePoint, CRM like Salesforce, Zoom call recordings, and so on. Wherever this data is residing, we are going to pull that out from there, bring it to a consolidated place so that we know it in its entirety, operate on it, transform it to make it more refined, cleaned, ready for consumption, and then create a gold layer out of it, and then feed it to various applications, be it AI agents or custom applications and so on. So we are applying the same framework, nothing changes there, just that we are operating on unstructured data now. So what kind of data we are talking about? Documents, audio, images, text, metadata, and so on. Now, the first thing is, if I am already collecting this data into object stores, which is a very common thing to do, because many of these applications natively work with object stores, or you have a pipe or a workflow which is already putting these files into an object store, like AWS S3, Azure Blob, or Google Cloud Storage. What you can really do is operate on this data without even having to move it into, say, Snowflake storage area. We can refer to this as a file. File is a new data type. You can refer to this as a file data type and operate on it with various functions like transcribe, complete, parse, and so on. Right? So the file is there. You're not moving it. You're just operating on that to get more insights from there. That removes the need for one more layer of ingestion, and we are able to operate wherever the file is residing. Yeah. Let's take an example of what do I want to do with this ingest step, right? So let's say we have legal contractual documents which are sitting in our SharePoint repository. The legal teams, the field teams basically work on SharePoint. And then we have structured data sitting in a database, maybe inside Snowflake, where we have the transactional details of that contract. What's the starting date, end date, so on and so forth, right? Now we want to associate that contract text, what were the SLAs we promised, along with what is there in the transactions data. How are we performing, validating the contracts, and so on. So we have two sets of data. One is in SharePoint, one is in Snowflake. How do we bring them together, just to validate and make sure the performance of the contracts is fine. What we recently introduced is a tool called OpenFlow, based on Apache NiFi. So if you're familiar with open source and Apache NiFi, it's a great tool for data movement. With OpenFlow, you can move data from any of the sources to actually any of the targets. Now, with Snowflake, we are obviously starting with Snowflake as a destination, but then you can actually take the data to anywhere. So there are a number of connectors already available, and there are continuously connectors being added on a regular basis. Yeah, so regardless of where the data is sitting, we can talk to that, bring it over into a single consolidated place. So let's look at in action. So we have SharePoint repository. We brought in this new file. It's not legible for most of the folks here in the room. But basically, left-hand side is SharePoint. We brought a new file into SharePoint. And on the right-hand side, we have the Snowflake console. We have basically configured a SharePoint connector. Now we are looking at the place where this data is being stored. And we can see that the new file has been populated already, right? So we are pulling over the file from SharePoint, brought it into the same consolidated storage. And then we can correlate them together. All right. So that's the first step, ingest the data, like how you ingest structured data. Let's look at the transform steps now, what we want to do in terms of things like classification, inferring the classes, extracting certain key fields, sentiments, classify that content, and make it ready for use. Yeah? Maybe validate that data, put some LLMs as a judge, or maybe human-in-the-loop validation. So you have two options there. You can either use general-purpose LLM models, which are very large models, which can do a number of activities. They're very flexible, right? Like OpenAI, Anthropic Cloud, or DeepSeek models, and so on. So you can continue to use those general-purpose models, and that option is available to you. Or you also have task-specific models, which are smaller in size, very cost-efficient, and purpose-built to perform those specific activities, like translating the content from one language to another, or doing sentiment detection, or extracting entities, or classifying, and so on. So that's a task-specific model. Now, depending on what you want to perform, you might want to use one of them. So let's look at both of them in a short way. So the first one, if I'm going to use a general-purpose model, frontier foundation model like Anthropic, DeepSeek, OpenAI, or so on, all I need to do is use this AI complete function. That's a SQL function inside Snowflake platform. I'm going to specify the model name. So if any of you who can read the text, it says Cloud Opus 4. Right? So that's the model I'm calling. And then I'm passing a prompt within the same SQL, a natural language text saying, hey, please summarize this customer feedback in less than 100 words. Yeah? And then you are saying, hey, this is the content. The content is coming from one of the sources in Snowflake. Like we pulled SharePoint data. This could be a content sitting in a table column. We are passing that content in the same SQL, and then we are specifying the table name. That's all we need to do. Choose the foundation model, add the prompt, and point it to the table where the data is residing. And that's it. That's all we need to do. Now, just like this AI complete, which can work on general-purpose foundation models, you also have functions which operate on these task-specific models. So there are a bunch of them here. There are more, but just to take few out of there, AI transcribe, it basically works on audio files. So if I want to operate on service center data and those .wav or .mp3 files, we can operate with AI transcribe, which can create transcript out of that. And then we can perform various type of analysis, like extracting entities, sentiments, what do we need to do in terms of the call center agents, and so on. Now, AI classify, same way. I'm looking at insurance claim document and seeing if this particular accident has had what kind of a damage. Or if I'm returning a shipment, how damaged is that shipment, right? Things like that. So there are a bunch of these SQL functions which we can make use of. And some of the use cases, again, you can categorize customer feedback, you can route the tickets to a right support forum, you can bucket loss opportunities into a particular area, and so on, right? So a number of things which you can do by automatically categorizing the data with these kind of functions. So this is one example. There is a damage in this particular image, and then all we are going to say is, hey, do AI classify, look at this image, and then say, is there a damage or no damage? So all I'm going to use is AI classify. I'm not even specifying what LLM model I'm going to use, because that is built in as a task-specific function. So now here we have a bunch of images, advertisement images, yeah? And what we are doing here is looking at those images. We are looking at what kind of image type it is, what kind of color type it is, and then classifying them, whether there's a human detected in that or not. Yeah. So these are all the images sitting inside the object storage. We are looking at this particular table created on top of that stage, and you can see the different definitions there: monochromous, complementary, neutral, and so on. And we want to compare that with what the ad impressions look like. All right. Now we can continue on this track with multiple things like extracting entities like brand images, extracting key themes from the documents. So if there is a particular economic document, we want to look at the GDP growth, so on and so forth. Yeah. Again, a bunch of things here in terms of extracting the brand names from these images. I'm just rushing it a little bit. But you can see here, it tells us the particular brand name from these images. All right. Let's look at the audio now. So there's a particular audio which the call center receives, and they want to then do entity sentiment out of this. What was the agent professionalism, the cost? Was the cost a concern? How much was the waiting time, and so on? So when we use this entity sentiment function, it basically looks at various entities which are there in the audio transcription and then takes it out. Yeah. So again, here we are doing this AI transcribe on top of support call tables. You can see .wav file. On the .wav file, we basically have AI transcribe running. And then after that function completes, it will basically extract various entities like agent professionalism, waiting time, cost, and resolution. At the end of the conversation, it appears that it was not a great conversation because the agent said, you do need a vacation. Now, needing a vacation is not necessarily a bad thing, right? But it appears that the conversation went in a slightly negative way because it ended up in that direction, right? So it basically says sentiment is negative, the agent professionalism was negative, and so on and so forth. Now, you can combine this with structured data. So for example, if I'm working on images, like in our campaign, we have the image of burgers, and we want to then see what kind of clicks and impressions it received. The clicks and impressions data is sitting in a structured table. The images data is sitting in a, on a stage, which is in S3, and we have created a directory table on that. And we can do an AI filter saying, hey, wherever the image is this, give me all those impressions of those marketing campaigns, right? So we are looking at images and then coming up with a tag, combining that with the structured data table, and getting the output back from there. Finally, once we have done all of this, we want to activate this with various applications, such as BI, AI tools, or agentic applications, or apps which are built on that. So there are a few apps available to you within Snowflake framework. There is Cortex Agent. What you can do with Cortex Agents is basically ask questions in your natural language. It kind of can create charts and dashboards for you. It can go across structured data and unstructured data. So it cuts across both of them, right? So you can see here Cortex Analyst, Cortex Search. But all you're going to do is you're going to talk to the agent API. And based on the type of question, it's going to route it to the right place. Recently, we also came up with this Snowflake Intelligence app. It's a ready-made application. It gives you the ability to play with the data without having to create a custom app of your own, right? So you can basically, also as a business user, you can log into this app directly without having to go to a Snowflake console, which is meant for data engineers. Log into that, ask your question as a business user, whether you're in HR, finance, operations, etc. Ask your questions and get the insights from there. with all these agents configured inside Snowflake Intelligence. So we can configure all these agents which are operating on that unstructured data, right? So end to end, this is what it looks like. You have all the data sets sitting on the storage layer, then bunch of compute running on top with LLMs, right, or even traditional SQL. And then finally, all these retrieval apps like agents, Cortex AI SQL, feeding these outputs back to you. So we talked about ingest, transform, and activate, the 3 layers of data pattern, right? We can call it bronze, silver, or gold. Once you create the data pattern, basically you are ripe to get the outputs or insights from your unstructured data. So just as a wrap up, number 1, before you go down deep into creating an AI strategy, think hard about your data strategy. Unless we figured out how we want to collect the data, we want to transform it and get insights, the AI strategy is not going to be great. Because whatever data we feed to AI, it's the same answers we are going to get. So the first step, keep the data governed, make all the right steps to make this data properly associated with the AI models. Number 2, the differentiators is not in the AI models. The models are commoditized now. Every week, like Mr. Rajgopal was saying, every week you have some new model coming up. The differentiator is your data. How do I bring the right data and get it in the right shape? That's the differentiator you can build on top, right? The way you transform your structured data and combine that, you can do the same things with unstructured data with these multimodal analysis with AI SQL functions, and you can do that in place with OpenFlow. All right? That's all from my side. Hope you got some insights onto how easily you can transform multimodal data with these AI SQL functions. Right. Thank you.